So in this video, I'll introduce the idea of the critical angle. This slide should look sort of familiar. Before, we looked at light coming down directly onto the interface, then we looked at it coming in at an angle to the interface. Now let's look at what happens if the angle that it's hitting the interface is right at 90 degrees. So if it comes right at 90 degrees, again, we try and line up these things, and the only way, since these distances are different than those, the only way you can line up these is at whatever this angle is. And when you work out this angle right here, it comes out to this, because the sine of 90 degrees up here is 1. So if that goes to 1, then the sine of something is just going to be a ratio of 2 of these things. So the sine theta critical is when the other sine goes to, well, it's at 90 degrees, so it goes to 1. So when n2 over n1 is equal to the sine of the angle in here, that's the maximum. If you tried to make it a different angle here, if you tried to make it more steep into this right here would have to go, it can't go any further. It would have to somehow be turning some other direction. It's already gone from here all the way to there. It can't keep going. If it kept going, it would actually be coming from inside. That's the only way to get it to be at the more shallow angle here, is if it came from the inside. That's what happens at the critical angle. So it's easier to think about maybe if instead of bringing the light in from here, you bring it in from below. Remember, you can reverse the ray diagrams, right? They're completely reversible. So if light comes in at this particular angle, then it will be completely horizontal coming out. So that is, again, at the critical angle. If you got to a shallower angle than the critical angle, then the light cannot get out. And the only thing you could do is reflect off that internal interface. And that is called total internal reflection. So here I'm going to demonstrate refraction and total internal reflection to you. I'm going to do that with this semicircular piece of acrylic. So I'm going to take the laser, and I've marked the center point there on it. So what I'm going to try and do is line up the laser, see if it's going straight through. If I aim it always toward the center, then it's always going to be normal to this surface, but it will change the angle with that surface. So for total internal reflection, you always have to be going from a higher index of refraction to a lower one. You can't do it from outside. It has to be from inside the higher index material. So as I turn it, you can see that this is still going pretty much straight through that intersection if I did it correctly, because it's hitting right at 90 degrees. But up here, from the normal vector, this angle's changing, that angle's changing. This is getting closer and closer to being completely parallel. When it gets completely parallel, there is no light at all that comes out of this surface. It is completely reflected off of this inside surface. Remember, this is not a mirror. This is just a surface between the acrylic and the glass. Light can get through it easily, but once you pass the critical angle, it can't pass through there at all. It all stays internal to the acrylic.